Hi, I'm Nico. I recently read in a book about silica aerogel, so I'm going to talk about that today. Have you ever heard of silica aerogel before? It's the lightest solid in the world, and 99.8% of it is air. It is made by removing water from a jelly whose internal skeleton is made from silicon dioxide. Removing water from the jelly is easier said than done. The water that fills the empty space in the silicon dioxide skeleton has surface tension. This surface tension is useful in that it keeps the jelly together, but when you want to remove the water by evaporation, surface tension apparently becomes our enemy. It causes the silicon dioxide structure to collapse when the water evaporates. So instead of evaporating the water, we put lots of pressure on the jelly while raising its temperature so that the water will be supercritical. At this point, there will be no difference between a gas and a liquid. By going through this supercritical phase, the water can apparently leave the jelly gently as gas without undergoing destructive evaporation. I didn't quite understand how this works though. Does this mean the surface tension disappears when the water becomes supercritical? Anyway, silica aerogel has a very interesting property. When you look up a picture of a silica aerogel, you'll find that it appears blue. But silicon dioxide, which consists silica aerogel, isn't blue. If silicon dioxide was blue, all quartz would be blue because quartz is made of silicon dioxide. Then why does silica aerogel appear blue? Look at the picture again. Doesn't that blue color of the aerogel resemble the color of the sky? Indeed, what makes silica aerogel appear blue is Rayleigh scattering, which causes the sky to look blue. Rayleigh scattering refers to the fact that shorter wavelengths of light get scattered more upon hitting molecules like O2 and N2 than longer wavelengths of light. I don't understand why this happens, but I'm not going deeper into that here. So, how does Rayleigh scattering make the sky appear blue? Longer wavelengths of light like red or yellow come straight through the atmosphere, so we only see them around the part of the sky where we see the sun. On the other hand, blue light gets scattered all over the sky before it reaches our eyes, so it appears as if blue light is coming from everywhere in the sky. Then, how does Rayleigh scattering apply to silica aerogel? The intricate silicon dioxide skeleton in an aerogel gives rise to billions and billions of tiny internal surfaces which scatters the incoming light by getting in the way of the light. In my understanding, when white light containing all wavelengths of visible light tries to pass through a silica aerogel, the aerogel selectively kind of traps the blue light and scatters it in all directions, including towards your eyes, making the aerogel appear blue. I also learned that silica aerogel has extremely powerful thermal insulation and the lowest refractive index of any solids. Silica aerogel is such a fascinating material.